This video is the 12th and final video on the complex number set of videos. In this video, we're going to look at transformations of complex numbers. This section explains how basic operations such as multiplying, dividing, adding and subtracting change the position of a complex number on the R-Gantt diagram. There are three main types of transformation. The first one is translation, which is just adding. The second one is scaling, which is multiplication by a real number. And the third one is rotation, which is multiplication by an imaginary number. Type 1 is translation by addition. If we take one complex number and add another complex number to it, the original complex number's position is moved as its real and imaginary parts are shifted. This is best explained by looking at an example. And in example 12.1, it says given that z1 is equal to 2 plus 2i, z2 is 6 plus i, z3 is minus 1 minus 2i, and z4 is minus 2 minus i. Plot z1, z2, and z3 on the R-Gantt diagram. To do that, first of all, we'll plot z1, which is 2 plus 2i, which when we plot on the R-Gantt diagram is here. The second one, z2, is 6 plus i, which is here on the R-Gantt diagram. And z3 is minus 1 minus 2i, which is here on the R-Gantt diagram. In part B, it says find and plot z1 plus z4, z2 plus z4, and z3 plus z4. First of all, I'm going to place B over here, and I'm going to find z1 plus z4. z1 is 2 plus 2i. z4 is minus 2 minus I. Here I'm going to add and subtract the real and then add and subtract the imaginary. First of all, I have 2 minus 2, which is 0. And then I have 2i minus I, which is plus I. Plotting that on the R-Gantt diagram, I'll do it in blue. We have 0 plus I, which is here, and that is z1 plus z4. Similarly, if we're looking at z2 plus z4, z2 is 6 plus I, and z4 is minus 2 minus I. We've 6 minus 2, which is 4. And we have I minus I, which is 0i. If we were to plot that on the R-Gantt diagram, it would be here. Finally, we're looking at z3 plus z4. z3 is minus 1 minus 2i. And z4 minus 2 minus I. Here we have minus 1 minus 2, which is minus 3, and minus 2i minus I, which is minus 3i. Plotting that on the R-Gantt diagram, we get minus 3 minus 3i, which is here, z3 plus z4. Now, if we look at how they've all moved, that's what it asks us in part C. If we compare what's happened, Z1 moved down 1 and across to the left 2. Z2 moved down 1 and across to the left 2. And Z3 moved down 1 and across to the left 2. So they've all done the exact same thing. They've all been translated from the point that they originally started at to a new point that's 1 down and 2 across on the R-Gantt diagram. So all you can say here is translation. And if you want to, as it says, describe the effect of adding z4 to these points, you could say all complex numbers moved one position down on the imaginary axis and 2 positions to the left on the real axis. The second type of transformation of a complex number we can have is scaling by multiplication with a real number. Multiplying a complex number by a real number changes its distance from the origin, so therefore its modulus changes. So for example, if a complex number z equal to a plus bi and a real number k, and you multiply z by k, well then the a is going to be multiplied by k and the b is going to be multiplied by k. And there's 3 important factors. So if k is greater than 1, the number moves further away from the origin, so it stretches or it gets longer, so its modulus gets bigger. And if k is between 0 and 1, the number moves closer to the origin, so basically its modulus gets smaller. Now, if k is negative, the number is scaled but in the opposite direction, so it's reversed. So it goes out but in the opposite direction from if it is positive. Again, as always, it's best explained by an example. An example 12.2 here, it says, given z1 is 3 plus I, z2 is minus 1 minus 2i, and k is equal to minus 2. Plot z1 and z2 on the Argand diagram. Hopefully you're okay with that. We'll start with z1, which is 3 plus I, meaning that it would be here on the Argand diagram. z2 is minus 1 minus 2i, which would be here on the Argand diagram. In part B, it says calculate and plot kz1 and kz2. First of all, we have kz1. K is minus 2 and z1 is 3 plus I. Multiplying out minus 2, it'll be minus 2 times 3 and minus 2 times I. That will leave us with minus 6 and minus 2i. If we're to plot that on the coordinate plane, we would go across to minus 6 on the real axis and down to minus 2 on the imaginary axis. So this is k times z1. Next, we have k times z2. K again is negative 2 and z2 is minus 1 minus 2i. Multiplying out the brackets again, negative 2 multiplied by negative 1, negative 2 multiplied by negative 2i. Negative 2 multiplied by negative 1 will give us 2. Negative 2 by negative 2i will give us plus 2i. Plotting that then on the coordinate plane, we have 2 plus 2i, which is here, and labelling that we have kz2. In C, it says, explain how multiplying by minus 2 changes the position of z1 and z2. As k is negative, first of all, the direction is reversed. So for example, if we look at here, z1, originally from the origin, it was going right on the real axis and up on the imaginary axis. However, if we look at kz1, which is here, from the origin, it is going left on the real axis and down on the imaginary axis. So the direction is reversed, but also ignoring the sign, we have the number 2, so k is greater than 1 in terms of ignoring the sign. And the fact that it is bigger than 1 means that it is moving further away from the origin. Or it stretches. So again, C says explain how multiplying by -2 changes the positions of Z1 and Z2. So first of all, K is negative, so the direction is reversed. And because the K number itself, ignoring the minus part, is bigger than 1, it stretches or moves further away from the origin. The last type of transformation we need to look at is rotation. Now, multiplying a complex number by I rotates it 90 degrees anti-clockwise, and multiplying it by -I rotates it 90 degrees clockwise. So for any complex number, Z, which is A plus BI, if you multiply that complex number Z by I, it's going to rotate it 90 degrees anti-clockwise, and we'll be left with -B plus AI. And if we multiply it by -I, we'll be left with B minus AI, which rotates 90 degrees clockwise. As usual, this is best explained by going through an example. Example 12.3 says, given Z is equal to 2 plus AI, in part A, find Z dash, where Z dash is equal to -IZ. Working out what the answer for that would be, well, we're looking here for -IZ. Z is equal to 2 plus I, so this becomes -I times 2 plus I, which will leave us with -2I minus I squared. As usual with complex numbers or with an imaginary number, I squared is equal to -1, so this becomes -2I minus -1. Then that becomes -2I plus 1, and we'll be left with the complex number 1 minus 2I. In part B, it says plot Z and Z dash on the Argand diagram below. So Z is 2 plus I, so if we plot that, it's going to be here. And if we're to plot Z dash on the Argand diagram, we have 1 minus 2I, which is here. Now, in part C, it says describe the rotation that took place. What's happened here is, as we've multiplied this by -I, it has rotated 90 degrees clockwise. And we can illustrate that or show that as if we join both of them back to the origin, you can hopefully see a right angle forming at the origin. If we had multiplied Z by I, it would have gone anti-clockwise and we would have been left with -1 plus 2I. In this video, we've looked at the 3 types of transformations you can be asked on complex numbers. The first one is translation, by adding a complex number to another complex number. The second is scaling, due to multiplication by a real number. And the third is rotation, by multiplication with an imaginary number. They're the only 3 that you can be asked on the exam. So as long as you know what happens each time you multiply by an imaginary number, or multiply by a real number, or add a complex number to another complex number, you'll be able to answer any type of question they ask on transformations of a complex number. That brings us to the end of this video.